We need to get bobbleheads made of us.
We do.
Yeah, they only do pairs.
Oh, come on, let's do triplets.
I looked, I couldn't find any.
Really?
Yeah.
I think it'd be a great idea.
I think it would be too.
Yeah.
Uh,
And then those who are driving to star parties, to put all three of us on
the back window.
the front window.
We
The front
get,
window.
oh, in the front window. Yeah.
You know, would be,
With the hula dancer.
yeah. And they could be replaying through YouTube our episodes.
Take the hula dancer head off and put our heads on.
There's an idea. Yeah. Hello, everybody.
Yeah. Hello.
Hey, I'm kind of lost here. We had our picture up first. That was kind of neat.
Yeah.
A little bit
Yeah, we're
easier
kinda
than looking at a bare screen.
Forgot we had an audience.
Yeah.
We are our audience.
We always forget we have an
Yeah,
audience. Yeah, we're our own audience.
Find
Okay.
a way to humor ourselves.
Good evening, everybody, and welcome back to our Sunday night offering of Astronomy Outreach, the Sunday night astronomy show.
Hey, I was in the middle of looking at something.
Jeez. Speaking of audience, you guys are even clued in. Okay, my name is Chris Kerwin of Astronomy by the Bay. I'm a member of the Royal Astronomical, and you're not. Member of the Royal Astronomical Society of Canada here in St. John. And first of all, I'd like to welcome back our regular co-host, Mr. Paul Owen from the Moonshadow Observatory in Hampton, New Brunswick. Evening, Paul.
Hello.
And we also have Mr. Mike Powell from the PFO Observatory here in St. John.
Oh.
Evening, Mike. Hey.
Oh, yeah. That's what happened to the observatory with snow. Oh.
Yeah.
Wasn't it?
Yeah.
You know, when you turn the dew heaters on and it starts to drip, that you've had snow inside.
I can show off my new mug,
Oh,
my
yes,
new
look at
Star
that.
Trek mug of
Oh.
all the different enterprises ever on the cup.
Oh.
Hey, it's a nice big cup too, so it might last about 10 minutes of the show.
I just watched the show, the episode today. It was the movie, the motion picture.
Oh, which one?
Yeah, where V'ger.
Oh,
The
V'ger,
first
yeah.
one, yeah.
Yeah.
The one that you fell asleep at.
Yeah.
Oh, V'ger, yeah, okay. Yeah, like
Longest movie ever. Yeah.
the hour long of the ship coming out of the dock. Yeah, okay. Anyway.
Yeah.
Okay. Let's go
But
back to the show.
That's when all the characters were starting to get into middle age, right?
Yeah, they were. Yep.
They all still look
But
good.
his toupee still looked the same though. He did a good job on that. Yep.
Yeah.
On tonight's episode of the Sunday Night Astronomy Show, you've decided to brave the cold. You've set up your gear, perhaps a telescope, perhaps camera, or even just binoculars. The time around new moon really was where we are right now is best for viewing those deep sky treasures. So what do you look for? Tonight we're going to investigate a few of those categories. Mike's going to take a look at something called open star clusters. M40, Mike, is in there? M40's in there?
You will see.
We'll talk about M40 in a minute.
You will see.
Paul will be talking about those beautiful nebula, like that one behind him in there. And I'll be looking at something we call globular clusters, which are not very popular this time of year, but we're going to take a look at why. And we'll reveal their design and their structures and why they make such great targets, all of them. Also tonight, Mike will have another Binal Bud treasure to share with us. Awesome. I didn't ask you that before the show started, but I was hoping it was going to be there.
You didn't. It's a secret.
Paul will offer up another interesting Rosanna's Fun Facts episode for us. Awesome.
Indeed.
Thank you, Rosanna. And I'll be revealing the best events to watch for in the coming week coming up. And we'll have all of your wonderful photo submissions to share as well. So sit back, grab your favorite beverage, and snack, and enjoy. And remember, this is a family-friendly live broadcast. Family-friendly, keywords. So if you have questions about the night sky or astronomy in general, we're happy to try to answer them here for you. So let's try to get started with our program. Welcome to everybody on Facebook and YouTube. Thanks for joining us, everyone. Got a whole pile of people on here already. Everybody fared pretty well through the blizzard, I hope. That was one pile of snow. I mean, in the front of the house there was nothing, and in the back of the house it was 4 feet deep. It's just weird. And I wasn't mostly on my neighbor's property either. It was mostly on mine. So anyway, yeah, it was a really crazy storm. I don't know what we got here locally, but I think they're calling for another 30 next week sometime. So anyway, we're in January. We're moving into February. We're getting closer. So we'll just keep our fingers crossed.
Tuesday, February.
Tuesday's February. That's right. Yeah. So already.
Tuesday is Groundhog Day.
Yes.
And then we got 26 more days and we're into March.
That's right.
Yay.
Speaking of days, I got a notice today saying that 1 year ago today was Astronomy by the Bay's 5th anniversary.
Yes, I saw that.
So now it's his 6th anniversary.
6th
Congratulations, Chris.
Thank you. Thank you.
Happy anniversary.
6 years. Yeah. I thought it was. I really thought. Yeah. I think it was. I thought it was February 1st. But anyway, if it come up today, it come up today. So
Yeah.
hard to remember back 6 years ago, but that was an awful.
Maybe it
That was a
was
lot.
or something.
I can't remember what I had for breakfast.
It might have been. Yeah. It might have been leap year. It was. They were different times for sure. I started up the page just because I was trying to get people to come visit me at the beach. People were asking me at the beach, when are you going to be back again? And I said, well, how do I go about that? My wife said, why don't you just set up a Facebook page? Okay, I'll do that. So I was going to call it Beach Bum Astronomy, but that didn't go over well with her. What's wrong with that? No, she said that wouldn't work. So anyway.
You need the dreadnoughts.
Yes. Yeah.
Right?
Which I did have the pork chops back in 1969.
And some ganja.
Yeah, and some ganja.
Yeah.
Yeah. 3-piece suit. Yeah.
And you dress
The
them
big
in.
heels. Yeah.
Oh, yeah, yeah.
Polyester suit. Anyway.
You got the fit coming around in your heels. Right?
Yeah. I never would have thought 6 years later we'd be sitting doing this kind of stuff, but it's been a lot of fun doing this program itself, and I've had an awesome. I can't believe that I've been lucky enough to share my passion with so many people. That's how many people get to do that in their own hobby, get to share it with so many people, and that's what I've loved the most about it. And I'm not an astrophysicist. I have no formal training at all in anything. Well, in air conditioning, that's what I do for a living, but just formal training. I'm not any good at it. But as far as astronomy goes, I've just picked up more of it from what you've asked me for questions. So when you ask me a question, I try to go research that answer. But all in all, the 5 years or 6 years, I guess now, it's up to a little over 10,000 likes right now, I think, and I think about 11,500 followers. So we're getting up there. We're getting good, and are getting larger numbers, which is great. And the more this gets shared out, the better that is too. So thank you all for the happy anniversary notices coming in. Really appreciate it, and it's been a lot of fun. Let's keep going. Okay, so let's start out with our first talk tonight. Who's going to be? You guys decide. Mike, I guess.
Entire screen show, right?
Yeah.
I think it's this one. Sure. All right. You should see open clusters.
Yes.
We do.
Well, I just wanted to talk a little bit about, what do we look at in the night sky when we go out? Well, you're either looking at an open cluster, a globular cluster, nebula, or eventually you get outside of that and start looking at galaxies. But I'm just going to do a quick little talk on open clusters and what are they? So a star cluster is a generic way for astronomers to refer to a group of stars that formed from the same material and gravitationally bound for at least some period of time. There are two major types of star clusters. One is a globular cluster, which Chris is going to talk to you about. And the other one is an open cluster, and they're actually quite different. Now, in the beginning, I got a lot of words here, and I can't read where the crap, so bear with me. Open clusters are very much younger and smaller than globular clusters. They are the recent birthplaces of new stars, which form out of clouds of dust and gas and contain only hundreds or thousands of stars, not millions or hundreds, just hundreds and thousands. Though the stars in an open cluster form together without some of the same material, they do not remain gravitationally bound over time, and they do spread out, scattering the stars far and wide. So the formation of an open cluster. The formation of an open cluster begins with the collapse of part of a giant molecular cloud, a cold, dense cloud of gas and dust containing up to many thousand times the mass of our sun. Many factors may disrupt the equilibrium of the giant molecular gas cloud, triggering a collapse and initiating the burst of star formation that can result in an open cluster. These include shock waves from nearby supernova, collisions with other clouds, or gravitational interactions. Even without external triggers, regions of cloud can reach conditions where they become unstable against collapse. The collapse of a cloud region will undergo fragmentation into even smaller clumps, including particularly dense form known as infrared dark clouds, eventually leading to the formation of up to several thousand stars. So basically, it's a big gas cloud that gravity pulls together, and you start getting star formations. There are over 1,100 known open clusters in our galaxy, but the true total may be 10 times higher than that because we can't see them all. We can't see the other side of the galaxy because there's too many stars and stuff in the way. In spiral galaxies, open clusters are largely found in the spiral arms where the densities are highest, and so most star formation occurs, and clusters usually disperse before they have time to travel beyond the spiral arm. So they open up and they disperse before they have a chance to leave, like a globular cluster does. Open clusters are strongly concentrated close to the galactic plane, with a scale height in our galaxy of about 180 light years, compared to a galactic radius of approximately 50,000 light years. So what all of that really means, when you look at this picture here, this is, say this was the Milky Way and we turned it sideways like a plate, so we're looking at it across the plane. The yellow dots are the ones that are showing you what are called globular clusters, and Chris will get into that. Over here on the left, you see a little black plus sign. That would be where about our sun is compared to the Andromeda Galaxy. And there's this thin blue line right in here, and it's actually on both sides. That's the area where open clusters are formed, just in that area. It doesn't go outside the plane of the galaxy, which I didn't know until I started researching some of this. Of all the open clusters, the Pleiades, which we all know, is the best known and perhaps the most thoroughly studied. This cluster, with a diameter of 35 light years at a distance of 440 light years, is composed of about 500 stars and is 1 million years old. And we all know the Pleiades cluster. We look and try to find those bright 7, but there's actually 500 stars in that cluster. Hard to believe. Another one that we all like to look at as an open cluster is the double cluster, known as Caldwell 14. Consists of open clusters NGC 869 and NGC 884, which are close together in the constellation Perseus, both visible to the naked eye. NGC 680 or 869 and NGC 884 lie at a distance of about 7,500 light years in the Perseus arm of the Milky Way galaxy. What a shot that is, man. That's incredible.
Yeah.
Another one that we don't think about as an open cluster, but it definitely is called the Hyades. It's not a Messier, right? It's the nearest open cluster and one of the best studied star clusters. Located about 153 light years away from the sun, it consists of roughly spherical group of 100 or hundreds of stars sharing the same age, place of origin, chemical characteristics, and motion through space. So they're actually related, all of these stars, somehow. It's not just you're looking and some of the stars are further away and some are closer. Well, that is by fact, but it's still they're related gravitationally. And then my favorite, ET. These are just some quick examples of open clusters. NGC 4057, known as the Owl Cluster or the ET Cluster, or now Wally if you're a younger person, is an open star cluster in the constellation Cassiopeia. It was discovered by William Herschel in 1787 and lies over 7,900 light years away from the sun. And its estimated age is 21 million years old. Two bright stars, Phi Cassiopeia and HD 7902, can be imagined as the eyes. And those are those two bright ones that we all look at. But yeah, a beautiful open cluster. And again, these are all gravitationally bound. So, what are the differences? Just quickly, I don't mean to take away from Chris's about globular clusters and open clusters, but an open cluster is a group of hundreds of stars instead of thousands. They're irregular shaped as opposed to spherical, like a ball. They contain bright blue stars, which are basically new stars or young stars. They're located in the arms of the Milky Way and not outside the arms. They're composed of young stars recently formed in the disk of the galaxy. and they continue to form in the spiral galaxies like the Milky Way. Here are, we all know Messier's, the Messier open clusters. I won't read them all off, but the northern summer open clusters, and then the northern winter open clusters, and the northern autumn open clusters. And here's just a couple of examples of them. But you can see where it can get confusing if it's a tight open cluster where you might think it's a globular cluster. It's not. It's still an open cluster because they're younger stars, not older stars. And look at this. This is just a shot of the Messier open clusters. Just incredible. Just incredible. And of course, a lot of nebula in there too, because it's being born. It's an area where stars are being created. Now, Chris, you asked. Messier 40, the wrong object. It's not an open cluster. It's not a globular cluster. It's not a galaxy, and it's not a nebula. What was he thinking? There you go. There's my little John on. How do I stop?
I noticed, Mike, on your shot of the Hyades or the Taurus.
Yeah.
There's actually a cluster right in behind it.
Yes, there is a smaller one. I forget the name of it right off the bat.
Yeah.
Yeah.
Yeah, very cool.
Yeah, we've joked a lot about Messier 40 because we said, Messier, all these 110 glorious objects, and Messier 40 is 2 stars.
2 stars.
Yeah.
I didn't know which 2 you're looking at.
Yeah.
Looking up and down the Milky Way.
Pick up any 2. Yeah.
2 stars.
Yeah. All kinds of Messier 40s in there. Yeah.
Car headlights could be SA 40.
Yeah.
Exactly.
We
Maybe
should
that's
follow
what
that.
the aliens are thinking. Hey. Bright light. Anyway.
I was just thinking, Chris, seeing that Mike did the open clusters, it would almost be better if he did it right now.
You just don't want to talk tonight, do you?
No, I know, but it just makes more sense to go
You're
right
right.
to them.
Yeah,
See if
absolutely.
everybody's, in cluster
Okay.
mode.
So give me a second. I'm going to get my presentation up here.
I don't know if any of that made any sense or not, but
Oh,
It all
well, then.
makes sense. And I had no idea that the ET cluster was that old.
yeah, me either. Wow, eh? We
Yeah.
look at it enough.
Yeah.
I didn't know Steven Spielberg was around that long.
Well, you
Yeah.
know that, you're right. He's getting old though.
He is getting old. Okay, let's try
I think
this.
the ET cluster is probably my favorite one to show when we do outreach.
Oh yeah, for
Yeah,
sure.
for sure.
It's so much fun,
It's
right?
on the right screen. Yeah, it is a lot of
Young
fun.
kid goes, "Who?"
Yeah. Now, when I share my screen, oh, go ahead. Sorry.
No, I was going to say it was called the Owl cluster before
Yeah.
Yeah.
ET, because obviously ET wasn't around until the 70s. But
Is
Anyway.
it 70s? Wow.
was it 70s or 80s?
I don't know. I feel old either way.
Yeah, either way.
Either way. Okay, I'm going to share my screen here, but mine unfortunately covers the whole view of the screen from you guys. So,
That's fine.
Aw.
the beginning. There we are. Okay, so globular clusters. A little talk on those. Mike did a little bit of an introduction on those. Open star clusters versus globular. I'm going to start out a little bit with a quick view of one of them here. Oh, hang on a second. It's not going to where I want it to go. Here we go. Why is it not playing? Go this way. Okay. So let's take a look at one of them. And this is just basically showing a 3D view. This is from ESA Hubble, one of Hubble's images, but several of Hubble's images actually combined to produce this image. And this is what it would look like if you're just outside the globular cluster looking in at it. Huge bundles of stars, anywhere from 10,000 to over 1 million stars in the bundle. Okay, so what are globular clusters? Well, the globular clusters are stable, tightly bound clusters of tens of thousands to millions of stars. They are associated with all types of galaxies. Globular clusters are typically much larger than open clusters and are tightly gravitationally bound. They are more densely populated, with populations ranging from tens of thousands to millions. The intense gravitational attraction between the closely packed stars gives globular clusters their regular spherical shape. Now, their considerable gravitational attraction makes them very stable, and therefore they can be extremely long-lived, surviving to be billions of years old. They are associated with all types of galaxies, and within the Milky Way they are found in the halo in the bulge. All star clusters are of great interest to astronomers because their constituent stars all formed at approximately the same time and location and had similar initial composition. Therefore, stellar clusters offer unique sights into how stars form and evolve. Globular clusters formed from giant molecular clouds or huge masses of gas that form stars as they collapse. Because there is less free gas available now excuse me, than there was at the beginning of the universe, globular clusters generally cannot form today. Each globular cluster moves as a whole in its host galaxy, but within the cluster, the stars also move individually and randomly, almost like molecules inside a gas. The individual motions of the stars act as a shield that stops them from eventually crashing into each other. However, gravity also acts as a glue to stop the star cluster from flying apart. Now, globular clusters also rotate, but not as much as a galaxy such as the Milky Way. That's because the original gas cloud of which the stars were created was also not rotating rapidly. So a typical rotation is between 5 to 10 kilometers per second. By contrast, the Milky Way rotates at about 250 kilometers per second. So how many are there? Well, astronomers have found a little over 150 so far that are orbiting our own Milky Way, and they orbit around the center. Here's a sample of some of the globular clusters. These of all the famous Messier objects in the list of 110 objects, 29 of those are actually globular clusters. And there are many more that are actually part of the NGC, or the New General Catalog list of deep sky objects. So there are over 200 of them now. This collage shows a range of globular clusters which were studied using Hubble and the MPG ESO 2.2 meter telescope at ESA's La Silla Observatory in Chile. The data shows that despite all forming at roughly the same time, the clusters all aged at dramatically different rates, with heavier stars sinking to the centers of the clusters in a process called sedimentation. The top row has Messier 4, Omega Centauri, which is the largest one, Messier 80, and then we have middle row Messier 53, Messier NGC 6752, and Messier 13, which is a very popular one in the summertime sky. Bottom row we have Messier 4, NGC 288, and 47 Tucanae, or Tucanae, I guess it's called. So here's a sample of another one. This one is actually a pan across M13. This is taken by Hubble as well. Or M3, I'm sorry. Messier 3, which is observable now. Colors of stars, the blue ones are the very young stars, the golder ones are about our color, the red ones are the hot, larger stars, red giants. Amazing images from Hubble.
Yeah, unbelievable.
We could all have a telescope like that. Now, the clusters are not unique to the Milky Way galaxy. Highlighted in this image are 136 of Sombrero's brightest globular clusters, taken by astrophotographer Rolf Wall Olsen from New Zealand. Now, this galaxy may have up to 1,900 in total in these satellite galaxies. Now, usually large elliptical galaxies typically have a greater concentration of clusters, such as the approximately 15,000 globular clusters that orbit the giant elliptical galaxy Messier 87. M87 contains several trillion stars. So here's all the globular clusters all around it. And M87 is visible in our wintertime sky. We'll see it here in a moment. So we do know that globular clusters are the oldest, largest, and most massive types of star clusters, and that they contain the oldest stars. Their age can be demonstrated by their almost complete lack of what astronomers call metals. That is, the elements that are heavier than hydrogen and helium that are present in the early universe before the first stars and galaxies were born. The heavier elements were forged into star interiors. Now, the globular clusters are big. They can reach anywhere from 300 light years in diameter and contain 10 million stars. Unlike the open star clusters containing sibling stars scattered throughout the disk of our galaxy and presumably other galaxies, globular clusters are actually big, symmetric, and very old. And here's the largest known globular cluster, Omega Centauri, containing as many as 10 million stars. Another little clip, which is I'm going to talk a little bit through it as we go through it here. I want to make sure that the volume is off, first of all. Yeah, okay. So the following video shows the movement of Bluestraggler stars in globular clusters over time. Bluestraggler stars are blue, bright stars with a higher mass than an average for a cluster, and they are expected to sink toward the center of a star cluster over time. Now, those closest to the cluster core are the first to migrate inwards, with more distant blue stragglers progressively moving inwards over time. A new study by using the NASA ESA Hubble Space Telescope and the MPG ESO 2.2 meter telescope has shown that not all globular clusters evolve at the same rate. While all globular clusters are old, over 10 billion years old, the stellar distribution within some remains youthful, with the blue straggler stars spread throughout the cluster. Others have aged prematurely, with the stars all located in the center. So that's how they're formed. So how would the sky appear if we were to transport Earth inside a globular cluster? This is a question I'd like to see when I'm offering M13 through the telescope. I ask people to picture themselves being inside a globular cluster. What would their sky look like? Well, two astronomers, William Harris and Jeremy Webb, designed a hypothetical Earth-like world orbiting a single main sequence star like ours, but one lacked a smack dab in the middle of 47 Tucanae, a globular cluster located 16,000 light years away from Earth. Now, this cluster packs about 570,000 stars in an expanse of space that's a mere 120 light years across. That's crazy. At the center, our planet would be surrounded by a few hundred stars per cubic light year, which is thousands of times the stellar density of the Sun's neighborhood in the Milky Way suburbs. The typical distance from our hypothetical planet to the closest star, however, still would be substantial, about 0.05 of a light year. It's 4 light years away to our closest star. In our solar system, this would place it just beyond the inner edge of the Oort cloud. Now, unless the closest stars happen to be red giants, none of them would have the angular diameters large enough to resolve with the human eye, so all the stars would still appear as points of light. Now, across the entire sky, though, inhabitants of our hypothetical world would see 10,000 stars brighter than first magnitude, compared with just 29 in our Earth sky, and more than 1,000 brighter than Earth's most brilliant nighttime star, Sirius. The brightest suns would blaze at an apparent magnitude brighter than -9, or 100 times brighter than Venus appears from Earth. More than 130,000 stars would shine brighter than 6 magnitude, the naked eye limit, compared to only 6,000 from Earth. So 20 times as many stars you would see in the sky as you do from Earth. Although it might sound like lots of empty space still exists at the cluster's center, the prospects for doing astronomy from there would be very discouraging. The biggest problem would be the sheer amount of light from all those stars. The cluster's suns would combine to give an average sky brightness some 20 times brighter than the Earth's night sky at full moon, or about 16.7 magnitudes per square arc second. In other words, the darkest night our viewers would ever see would be a strange sort of twilight that possesses a kind of grainy texture, unlike the uniform sheet of light we see here on Earth. Now, the galaxy's disk, already hard to see from the Earth at the full moon, except from isolated locations, would be visible in the background, but hard to study. Astronomers on our hypothetical planet likely would favor telescopes with very small fields of view and excellent baffling against scattered light. And one final clip here is a zoom in on Messier 13 from Hubble. Oh, to be a spaceship flying in at this.
Left, Sulu, left.
And I love how Hubble resolves stuff, right? So that's M13. As we don't see it like that through our telescopes at the beach.
No.
But, that's Hubble's version.
Wow.
So quickly, what do we have for locations to see things? Okay, well, if we were out tonight, from looking from northeast to southwest, these are the globular clusters that you would find. And now I use the program called Stellarium. You can download that from stellarium.org. I just went into the menu and chose globular clusters. That's all I wanted to see. And these are anything about magnitude 3 and up, I believe it was. So there's Messier 79, that one with 1 trillion stars in it right there. And there's a number of other ones here as well, M92. These are, so anything that's, if you use the program, you'll see little plus signs when you click on the deep sky objects. That's what brings them up. So there's not a whole lot of them in the wintertime sky. Excuse me again. There's Orion sitting up here, so most of them down below Orion. So this is at 11 o'clock tonight. If we looked at our northeast part of our sky at midnight tomorrow, there's a few M92, and there comes Hercules. This is, we're looking at M13. That's the one we just viewed a minute ago. So that's a very tight globular cluster here, more loosely one here, but this one has over 500,000 stars in it. Those are more summertime objects. Looking southwest at midnight tomorrow, okay, a couple others, M79 and NGC 2298 as well. Not too hard to find if you use Stellarium to find them. But look at our summertime sky. Everything changes then, because at this time of year, we're looking back into Sagittarius. Here's the center of our Milky Way right in this area. So this would be the large bulge that is the center of our Milky Way, and the globs, most of the globular clusters surround the center, the core of our Milky Way. So that's what our sky looks like in the summertime. If we want to go hunting for globular clusters, there's all kinds of treasures here to find. And you don't need a large telescope. A 10-inch telescope and up will get all of these, but 8-inch telescope would certainly reveal a lot of them. And even a 6-inch will get a lot of the major ones like M22 and M13, that kind of thing. So that was it. That's my talk on globular clusters.
Wow.
That's crazy, the amount of stars in there.
Oh,
That's crazy.
You know, it's a shame that that Hubble is now out of service. We've got the James Webb, which is great, but it's a different type of telescope. A lot of people think they're going to get more Hubble images, but it's not true color images. It's infrared. It's a totally different thing.
Yeah.
And it's a totally different mission.
Right.
And but the Hubble, those globular clusters, there's nobody on Earth that could image those the way that the Hubble did, because of the resolution that you would have to have, and you lose a lot of that just from going from Earth's surface out to space. Number one, but then we're using optics like this as opposed to 3 feet.
Yeah.
Yeah.
In space, yeah, where you don't have any you don't have any interference at all. I mean, Hubble's not done yet. Hubble's still working, and the idea is that Hubble and Webb are supposed to stare at the same target. So they may be looking at targets in optical light, and I think Hubble uses UV light as well. But James Webb will be using infrared, so they'll both be looking at the same targets. Too bad Chandra wasn't still up there too, because we'd have X-ray as well, so we get a full gamut of what's out there. But they are going to partner up apparently in a few missions. Maybe to look at exoplanets might be one of the bigger things that they're going to look at together. But yeah, I mean, Hubble's just been what a
I think Elon Musk and the Amazon fella there should put their money together and go get Hubble and bring it back for the Smithsonian.
Absolutely, Mike. I agree 100%.
Yeah,
they shouldn't let that
burn up.
Why let that burn up in the atmosphere? Why not? They'd have the technology to go get it and bring it back. Sure they would. Yeah. We can bring a rocket back down from Musk. I mean, why couldn't they bring that down? So.
And they got the money. So.
Yeah. It would be amazing to see something like that. Anyway, okay.
Space junk too.
Yeah, that's right. Absolutely. Okay, Paul, you're up.
All right. Okay. So I'm not going to get as in depth as you gentlemen did on what I'm going to talk about, but however, hopefully you get something from it. And what I'm going to talk about is nebulosity. Now, it's a topic that a lot of people, I guess, just getting into astronomy, may not know a lot about, other than they think of the Orion Nebula. When you think of nebulosity, it's the first thing you think. It's a naked eye nebula. It's certainly a binocular target. It's one of the first things you see, and if you ever get into imaging, it's one of the first pictures you take. So that's probably the most famous nebula or type of nebula. But there are more than one type of nebula out there, and that's what my little chat's going to be about. So let's talk about nebulosity. So what types of nebula are out there? So there is reflection nebula, and I'll get into these into definition as we go through, because there's only 5, so it's a very short chat. There's emission nebula, there's planetary nebula, there's dark nebula, and there's actually supernova remnants. And yeah, so there's quite a few there that I asked. I think we were at a Star Party once, and I asked the question, how many nebulas are out there? And most people could think of 4, they couldn't think of 5. So it was kind of interesting. Even people that are around us are unfamiliar with some of it. So reflection nebulas, we'll start with that. Now, again, I think everybody showed a picture of Pleiades, and it's a beautiful, nice naked eye target, but you'd never see the nebulosity with your eye. So in order to be able to see the nebulosity from Pleiades, you'd have to either image it or have an extremely dark sky with a really big mirror to be able to see some of it. So reflection nebula are clouds of dust which are simply reflecting the light, and that's all they do. And it's light that's comes from nearby stars. And so reflection nebula are also sites of star formation. So as Mike was saying earlier, wherever you see nebulosity, you're typically seeing star nurseries. There's some kind of stars being born somewhere around nebulosity. And these reflections are usually blue because the scattering is far more efficient for blue light. And reflection nebula and emission nebula are often seen together and are sometimes both referred to as diffuse nebula. I looked up the word diffuse, and it just simply means something that's spread over a large area where it's really hard to tell beginning and end. So that's what that means. Emission nebula is a little different. Now, emission nebula are the things that we would see, say, like, for example, this is what they call the wall, the Great Wall in the North American Nebula. But anything that's got that red hydrogen alpha kind of glow to it is emission nebula. Now, emission nebula are clouds of high temperature gas. The atoms in the cloud are energized by ultraviolet light from a nearby star, and they emit radiation as they fall back into lower into lower energy states. Now, these nebulae are usually red because the predominant emission line of hydrogen, and when we talk about imaging things, there's certain filters we use. So when you use a hydrogen alpha filter, which people have heard of, this is the kind of color that you're trying to zone in on. So these nebulae are usually red because of the predominant emission line of hydrogen happens to be red. Other colors are produced by other atoms, but hydrogen is by far the most abundant. And emission nebulae are usually the sites of recent and ongoing star formation. So again, another spot where you're going to see a lot of star life beginning. Now, there's also planetary nebula. Now, planetary nebula have nothing to do with planets. So let's just talk a little bit about that. So planetary nebula are basically the shells of gas that are thrown out by some stars near the end of their lives. And our sun will probably produce a planetary nebula in about 5 billion years. They have nothing at all to do with the planets. The terminology was invented because they often look like little planets in small telescopes. A typical planetary nebula is less than 1 light year across. So typically planetary nebulas are not that big. This one, M27, is very famous, same as M57, which is the smoke ring?
The ring. Ring nebula. Yeah.
Yeah. Anyway, there's a lot of them up there. There's all kinds of planetary nebulas up. The Helix is one. Anyway, they're really cool to see in telescopes. And in fact, this particular one, some people call it the Apple Core, but it's called the dumbbell. And Mike and I actually looked at this one through bino viewers at a dark sky site, and this is an amazing target to look at because you won't see the color, but you will see the cloud, and it's very, very evident. So if you ever get a chance to find M27, look it up. It's easy to find, and it's just a wonderful target to look at. Now, there's also dark nebula. Now, what dark nebula is are clouds of dust which simply blocking the light from whatever's behind it. The Horsehead is a perfect example of that. The Horsehead itself is just a big bunch of dark gas, and if you ever zoomed in on this photograph or any Horsehead photograph, you'll start to see that you have to get in really, really close, and you see about 4 or 5 stars that actually are having a very hard time penetrating that dark gas. But if you get close enough, you can see it come through. Typically, those stars would be, and those stars that are coming through that dark nebula are actually part of the star system that's igniting that hydrogen alpha that you see in behind the Horsehead itself. So dark nebula and clouds of dust, which are simply blocking the light from whatever's behind, they're physically very similar to reflection nebula, and they look different only because of the geometry of the light source, the cloud and the Earth. Dark nebula are also seen in conjunction with reflection and emission nebula, and a typical diffuse nebula is a few hundred light years across. So what they're talking, of course, is any of these blue nebulas that you see. These are reflection. Of course, that's the dark nebula. That's emission nebula. So there's all kinds of stuff going on in that particular region of the sky. By the way, that's in Orion's belt, if you ever want to see that. Now, there's also supernova remnants, and there's a ton of these up there. And I didn't know until I shot this that this particular target is a supernova remnant. And so a supernova occur when a massive star ends its life in an amazing blaze of glory. And for a few days, the supernova emits as much energy as a whole galaxy. It's hard to believe. But when it's all over, a large fraction of the star is blown into space and as a supernova remnant. And a typical supernova remnant is at most a few light years across. So most of the supernova remnants are really not that big unless they just keep spreading further apart. So if you look at the eastern, the western veil, and the one in the middle, I can never remember what's it called? Pickering's triangle in the center of it. That's also a supernova remnant some 8,000 years ago, and that's actually looks like it's drifting further and further apart. We'll never see the difference, but in any event, that's what supernova remnants are. And there's one there. There's the western veil. Easy to detect because it's got that really bright star right above it. But that's a supernova remnant as well. So they don't necessarily have to be round or any specific shape, although these would have started out round if you saw the whole complex, but it just over time it would have pulled apart. So supernova occur when a massive star ends its life and so on. So I won't read that again because it's the same thing. Now, diffuse nebula and H2 regions.
Can I pause you for a second, Paul?
Yeah.
Because I just want to comment to everybody that these are Paul's photographs.
Oh.
Everything that he's been showing through the presentation so far has been all Paul's images. So congratulations, Paul. They're fantastic.
Oh, thank you so much. It's how I learn about this stuff. You got to look when you're taking pictures and stuff. You got to figure out, okay, there's hydrogen alpha in here. How do I get it? Anyway, speaking of that, so a diffuse nebula and H2 regions. This is really interesting. This is kind of what gets me more excited about this stuff. A cloud of interstellar gas and dust, which grows because of the effect of it, of the ultraviolet radiation from nearby stars. The term H2 region is now preferred. The description diffuse dates from the earlier times when nebulae were more defined according to their optical appearance. A diffuse nebula was one which retained its fuzzy appearance under magnification through a large telescope, as opposed to one which could be resolved into stars. Now, if I can't blow this up, but we talked about different regions, and this is actually a galaxy. This is the Andromeda galaxy. But if you look at all those little, and I wish I could make this bigger, but if you look at all those little jewels, those little pink areas, those are all hydrogen alpha regions where stars are actually being formed. And also, there are all kinds of these blue stars going into that same form. And these clusters, when you look at them close up, are absolutely amazing. And the only way to see this kind of stuff in Andromeda is to actually photograph it and get as high resolution as you can, blow the image up, and then take a tour. And I'm telling you, it's one of the reasons why I do astrophotography, is so that I can actually see deeper into these structures. And anyway, it's amazing. I do happen to have a link on here. I'm going to click on it, and I'll see where it actually shows up. There it is. And this is a list of diffuse nebula. This is not a complete list, and this is under Wikipedia. So you can just look up, well, that link that I gave to you there, but it's just under Wikipedia. And this is the list of all diffuse nebulas, and there's more. So, because Wikipedia is the kind of place where you can actually add to their information, you can do that. And anyway, it's just a great source and whatnot. So I really enjoyed that. So whoops. Am I still around?
Yeah.
Okay. I need to stop sharing.
Yeah, you're still here.
There. Are we back?
We still get your screen. There we go. Now you're back. Hey, there we go.
Anyway, that's a little bit about nebula and the different types of nebula that are up there, and a little bit about formation and how we grew from the Messier days, and even back further than that, into the Galilean days where he saw these things and thought they were one thing, but because of the very limited optics, as we have today, as time evolved, we can start to see things in a much different light, and so be it. Speak of the Hubble and the James Webb.
Awesome, Paul. Thanks very much.
Yeah.
We'll do. We know that there are more categories there. Galaxies are, of course, the big one. We haven't really talked about those, so we'll save that one for galaxy season as we move our way closer to galaxy season, which is coming up pretty soon. Not that far away. Virgo gets up nice, and then Leo's behind that. And Paul, listening? I think he's listening.
I am. When you say Leo, I just, for some reason, I get that. Jar Jar Binks?
Yeah. Also, me shall not know that. Yeah. Anyway, okay. Let's go from there. We're going to be a little long tonight, folks. It's 10 to 9. Obviously, we still got 3 more little short talks to do and our photo. So we could be 9:30. We're stretching it into. We are getting into a longer than an hour. It's inevitable, I think, because we get into 3 different talks, and these are talks that are a little bit in depth, and I get talking a lot too. I know that, but maybe that's half the problem. I just shut up. I just shut up once in a while. Anyway,
next slide.
Next slide. To let you know that we are going to run a little bit long tonight, so we'll probably be 9:15 or so. Anyway, let's keep moving. Keep moving. Who's next? Yeah, that's it.
What's on first?
Mike is up next. Bino Bud. Yeah. Let's do a Bino Bud talk. What does Bino Bud have to reveal this week?
Bino Bud this week. It should be coming up here.
There he is.
Target of the week by Bino Bud is Mullet 111, or Berenice's hair. You go, what? What's that? Well, the Coma star cluster, also known as Mullet 111 or Colander 256, is a small but nearby open cluster located in the constellation Coma Berenices. The cluster contains about 40 bright stars between magnitudes 5 and 10. The brighter stars of the cluster make a distinctive V shape when seen when Coma Berenices is rising. The cluster used to represent the tail of Leo at one time. However, around 240 BC, Ptolemy, I tried to get that name right, 3, renamed it for the Egyptian queen Berenice's legendary sacrifice of her hair to the goddess Aphrodite. How do I find it in the sky? Well, if you go outside about 11 o'clock tonight and it's clear and look 90 degrees to the east or due east, you'll start seeing Leo climbing up. And we all know Leo. We can look at it. And like Chris says, we're hoping for that galaxy season. And there's that bunch of galaxies right down in here. But instead, you look across towards where Berenice's here, and you'll see there's a kind of like a bright spot right here at the top. And that is Millet 111. So you look in here, there's why it was called the tail of Leo, because it looked like a tail on the back of the lion, but it was changed over, and it looks like the lock of hair that was sacrificed for Aphrodite. But it's right there in the Coma cluster, right at the top corner, about 240 light years away. What will you see? This is the cluster that you're going to be looking at, and it stands out quite nicely against the background. In 10 by 50 binoculars, take a look at this. It's huge. So you can't miss it. When you're scanning across from Leo and you come across that, you're going to go, wow, there she be.
It is big.
No question. Compare it to the full moon. And look at that. It's got to be 6, 7 full moons in diameter. So it is pretty big. And keeping up with our thing about telescopes, this is going to be the first image from the James Webb telescope.
Oops.
Whoops.
That guy lost his job. I hope not, Mike. I hope not.
That's great.
That's on the secondary mirror. Nobody saw it. It was on the secondary mirror. Crap.
I saw that. I couldn't resist it. That just cracked me right up.
Yeah, everybody's looking at that nice gold polish and forget about the secondary.
Yeah.
Oh, well.
Remove before flight.
Awesome. Thanks, Mike. Appreciate that. Another great target. Another good treasure. Mr. Paul, would you like to come up again now with Rosanna's fun facts?
I would indeed. This one's actually, well, all of Rosanna's are good. I keep saying that every week, but they just seem to get more interesting.
Absolutely.
Oh, yeah.
All right, let me just get this all set up here, and let me see if I can do this correctly. And this is this week's
Rosanna's Fun Fact.
Yeah. Well, hello, Rosanna, and welcome back again for another one of your great fun facts. And this one, I'm actually going to have some fun reading. So, or I'm going to try to read it anyway. Like you, Mike, I'm not a great reader, but here we go. Anyway, she says, hi, Paul. Inspiration can be a hard thing to find at times. People look in all sorts of places to find it, and possibly this explains the higher sales at the liquor store during the recent level 3 lockdown. Are you drinking in lockdown? Look where the X is. Oh, but most of us still find inspiration quite easily in gazing skyward. Whether seeking sunspots, creating fabulous astrophotos, or just enjoying the constellations in the Milky Way, nature is fabulous. Stars, galaxies, and comets have inspired artists, poets, musicians, and the humble human for over thousands of years. Fairly recently, the galaxies have inspired an apple. Not the creation of the apple. Not the creation of the apple, but that has been in the works for a few years. I suspect that Prophet inspired that, but certainly in the naming of the final development, drum roll please, is the Cosmic Crisp. It is coming to a grocery store near you soon. Here's a pic my younger brother sent as he found one and ate it. Now, you might think that the name Cosmic Crisp is just a marketing ploy, but no. If you read about it, the creation of this new apple, it truly ended up being called Cosmic because its unique peel, and it's very appealing. So WA-38's lenticles look exceptionally bright against its inky skin, and this reminded some in a focus group of the stars in the night sky, an observation that became trademarked as the cosmic crisp. It's the first apple that's ever been named by consumers, said Catherine Grandy. Now, if you go to this article, and there's an article, I won't show that, but we'll learn more about apples than you could ever have wanted to know. Now, the space apple started me wondering about how many astronomical connections could I possibly find? So Draco is one of the first 48 constellations cataloged by the Greek astronomer Ptolemy, and in the 2nd century. One myth involving Draco, known as the Dragon Laden, is that he was guarding the golden apple tree that belonged to Hera. Now, Hera was presented with 3 golden apples upon her wedding to Zeus. Hercules, as part of his 11th labor, killed Laden and carried the golden apples away. Now, saddened by the death of the dragon, Hera or Zeus put him in the sky forever to be the constellation Draco. Now, there are other versions of this story, and some Laden is not slain. The golden apples represent various ideas of themes and appear in the Greek myths and often in mythologies. I also found a rare reference entitled Non-Newtonian Fable Apples in Astronomy, 1854. Notes by the author of this post, J.F. Patak, Science Books. Now, after all this time handling, reading, browsing books in the Library of Science, I believe I've never seen an illustration, an astronomy text utilizing an apple to demonstrate the sphere or globe, and here it is. I'll make that a little bigger. So these 2 apples are put together so that no plane can be seen. We can now imagine the plane to be extended out to any desired distance from the apple, like this paper circle, which is inserted between the 2 halves. The circumference and the diameter of any great circle or of a sphere is the circumference and diameter of that sphere. Any diameter may be termed an axis. Continuing the astronomical apple quest, I discovered that should I be able to travel, I could go to Boston on Thursday of this week for apple cider and astronomy. And the location, it tells you that she gives it, that's in Boston, of course. And I would truly wish I could go. Oh, and for $13, just join us for a night of warm cider under the stars. We will stargaze using a telescope and star charts, take a night hike, and enjoy apple cider as we take in the majesty of the changing seasons. I truly wish I could go. And in October of this year, there was this. Now, this is not New Brunswick's Minto, but this was in Minto. Oops, did I not take that picture? Oh, I know what it is. This one's that. There we go. Apples and Astronomy event, part of Cultural Days in Minto. So there is also a cool chart for kids or people like me on the site, thelaughing-squid.com, equating Uranus to the apple. So how big are the planets? Here are the relative sizes of the planets of our solar system. The sun is so enormous that you could fit over 1 million Earths inside it, which is why we couldn't fit it on this page. So it shows everything else that's in there except for, of course, the sun. Now, probably the best laugh came from this song, A Very Beatleish Apple Pie in the Sky. And I'll see if you can hear this.
I often sit and gaze into the sky and dream about a slice of apple pie. But then I sit and ruminate, cause apples give me bellyache. So apple pie, my friend, I'll pass you by. The apple pie in the sky, I wonder why your pie has flown sky high. meditating on a
So if you want to hear it's called Apple Pie in the Sky by John Isherwood. Oh my gosh, I love it.
That's cool.
It's got that Bo Diddley thing going on too, eh? So since it's a blustery, blizzardy day, quite completely hiding in the sky, I might as well go make some pie. And apple, of course. Oh my gosh, that is just so amazing. And that is this week's.
There we go.
Rosanna's Fun Fact.
Yay!
Yay!
Isn't that uplifting and
That's
fun?
cool.
I'm hungry.
It's so good.
Apple pie.
Maybe one of
Had to
them
say apple
apples, huh?
pie. My favorite.
How do you like them apples?
Yeah. Or watermelons.
Oh,
Thank
that's
you,
fantastic.
Rosanna, again for another fantastic segment.
Oh, that's just amazing.
I
I
know
would
she gets
never
it,
have
but
thought the Earth being a cherry tomato.
yeah. That's why we don't get squashed like one.
Yeah.
Yeah, that's right.
Okay, we're going to go from that. Thank you, Rosanna, once again, and we're going to go from that to our, I guess, what's up in the sky. So this week, that'd be me. I think, and then we're going to go to photos, and that'll be our evening. Okay, let me share my screen. We should be going from. Okay, let's take a look at what's coming up this week in our night sky. Not a whole lot going on, but there's a few things. First off, of course, Tuesday, February 1st is our new moon. Our new moon is new. Our new moon is new. Yeah, our moon is also new on Tuesday, meaning that it's located between us and the sun. This marks for dark evenings without the light pollution of the bright moon, allowing you to see more of those faint deep sky treasures, those open clusters, globular clusters, nebula, all those pretty things that we like to see and give a chance to get out and enjoy on these colder winter evenings. Monday, tomorrow now, moon is at perigee. On Monday evening, our moon is at perigee. It's closest approach to us. The moon reaches perigee, the closest point in its orbit to our planet, at 3:11 a.m. Atlantic time. At that time, it will sit just 362,252 kilometers away. Now, perigee moon usually means higher than normal tides as well. Wednesday, a few things happening Wednesday now. Wednesday, February 2nd, the moon will be near Jupiter. So we've got a very slim crescent moon coming up in our evening skies. We start our cycle all over again. Watch for our early evening waxing crescent moon on Wednesday night as it greets Jupiter in the southwestern sky after sunset. Now the two will be less than 4 degrees apart, which means they'll be visible together in most binoculars. There's another great photo op. So if you have a small telescope and you want to attach your cell phone to the telescope and get a picture of Jupiter and the waxing moon together, great shot. Mercury in the morning sky by midweek. Our morning sky show continues to get better as little Mercury joins brilliant Venus and reddish Mars by midweek. All 4 rocky worlds are visible. 4? Well, there's 3, and the one that look down at your feet, you'll see the 4th one. Expect this planetary lineup to continue until at least the beginning of March, when Saturn will join the show, and then that will replace Mercury as the newest morning planet. So Mercury will start to disappear, and Saturn will pop up. Got some really nice planetary alignments coming up over the next few months for sure. Of course, Groundhog Day on Wednesday. The first, of course, is not an official Groundhog Day celebration. Took place back on February the 2nd of 1887 in Paxitawny, thank you, Pennsylvania. Pennsylvania. It was the brainchild of local newspaper editor Clymer Fries, who sold a group of businessmen and groundhog hunters, known collectively as the Paxitawny Groundhog Club, on the idea. Of course, it doesn't have any astronomical event significance, but I think some of us really reach for any hope of an early spring. So what do you think, an early spring? Come on, yeah. Got to be after this week. On Friday, February 4th, Saturn is at opposition. Well, Friday, the ring beauty, Saturn's at superior conjunction. Sorry, not at opposition. That's wrong. superior conjunction. This means that Saturn is on the opposite side of the Sun from our point of view. What this also means is that soon Saturn will join the rocky worlds of Mercury, Venus, and Mars in our morning sky very soon. So it's over here, not at opposition, over here. Opposition comes up in August of this year. All week long, the winter hexagon is at its best when our moon is in its new phase, and for about a week after, it's a great time to glance back at the universe. One of the many asterisms we get to enjoy at this time of year is one called the winter hexagon. Now, the huge hexagon comprises several constellations, and it's outlined by the stars Capella in Auriga, Aldebaran in Taurus, Rigel in Orion, Sirius in Canis Major, Procyon in Canis Minor, and Castor and Pollux in Gemini the Twins. So, big piece of sky, huge piece of sky. I don't know if you can get it all in one shot. I've tried to get it all in one shot before with a camera, but haven't been able to.
I got it with an 8mm lens. That's it.
8mm, yeah. It's a big piece of sky. A lot in there. The next few weeks, the zodiacal light. Paul, this is your photo. This glows as zodiacal light created by sunlight scattering off myriad grains of dust spread throughout the solar system and aligned with the ecliptic, that plane of the solar system that planets and the moon seem to take across the sky. Astronomers believe this dust is the debris left behind by countless comets approaching the sun, although recent research suggests that it might be dust from the planet Mars when Mars gets into a dust storm. Yeah, so that's the glow that you'll see here, pyramid kind of a shape in the early morning sky in the spring and early evening in the fall. That's Paul's capture from, where's that at, Paul?
It was with Trudy. I was at
Split Rock.
Split Rock, yeah.
Right there, there's Split Rock, yeah. And that's about all. That's about all we got for the events this week. Anyway.
You gotta love it.
There are, the activities are less, in the next couple of weeks or so. The events, there's not a whole lot happening, but we've got a busy year this year. A lot of planetary alignments coming up, a lot of conjunctions, a lot of special conjunctions where planets are going to be very close together. It's going to be hard to separate them with your naked eye. We've got 2 lunar eclipses coming this year. We're all leading up to that great solar eclipse coming up in 2024. So there's a whole lot happening all year. And leads up to, at the very end of the year, we've got the moon is going to occult Mars. So that's one to catch. Mars will be there and moon will pass in front of it, which will be really cool. We'll be live that day. It'll be cloudy that day, so we won't have to worry about it. Won't have to worry about it. Okay, let's get to some photos now. And I want to bring up my little bit of a notes I got here. Okay, I just need to get to our first photo first of all. I didn't share my screen, so you guys aren't seeing it, but let me share my screen first. Okay, now
there we go.
I'll go to here. And image is up. I just want to get my photo notes. There we are. You guys see the image okay?
Yeah.
Okay, all right, so this one's from Jamie, why not? Jamie says, hi, Chris, I took these photos Wednesday evening. The first one is of the ISS passing through the trees. There it is. We had lots of nice views of the ISS over the past week. And the second one is of the winter hexagon. There we go. Part of the winter hexagon, she says. Procyon, Orion, and Sirius. Yep, there's Sirius, there's Rigel, Procyon, Castor and Pollux, I think she's got in there. Both taken with my iPhone 8, she says. Awesome.
Nice.
Thanks, Jamie. Yes, Matthew Dupre says, I was out the past few nights enjoying the cold. He certainly captured a nice shot there.
Oh, yeah.
Of Orion, yeah.
I like to tell his rig in the in the beginning.
We were talking about this tonight, I think, about getting a camera cozy we were talking about, because he said he lost a part of his battery power real quick.
Yeah.
So there's a nice capture.
That's beautiful.
Gorgeous.
And another.
Wow.
Yes.
Well,
looks like he's got Orion sitting there, yeah.
Yeah.
Yeah, it's so easy to spot. And another.
Oh, very nice.
Oh, look at that. Yes, sir. Barnard's Loop and you got Horsehead in there, the Flame, Orion, Running Man.
Wow.
Beautiful. Great.
Rigel down there. I can see a little bit of the witch
Witch
head.
head?
Witch
Yeah.
head?
Yeah.
Yep.
A little bit of blue in there.
Down in here.
Yep, down
Yeah.
by Rigel. Yeah.
Right by that star. Yeah.
And in fact, it's very close to Rigel. Yeah.
Yeah. I get a better
I think
view here.
Rigel's what lights it up.
Yeah, right in here.
Yep.
Yeah, awesome. Thanks, Matthew.
Beautiful. Great work.
Great work. Okay, next we've got this one from Lisa. Lisa says, "Hi, Chris. I've been practicing my stacking and composite images for some of the great events coming up in 2022. If weather ever permits," she says. "This week I managed to get a composite of the setting moon that I'm really pleased with, so I thought I'd share."
That's so cool.
Nice.
Good
Really
night
nice.
moon, she says. Almost last quarter, 59%. Images taken every 3 minutes, extracted from video, taken on iPhone 11, stacked in Starry Sky Stacker on January the 24th at 7:34 Eastern Time. She says, keep on keeping everyone motivated to look up. We do our best. Great shot.
Fantastic. Great shot.
Well done.
Nicely done, Lisa. This is Brad's. I thought I had Lisa's other one in there. I don't have it. I'll have to find it after. This comes from Brad Perry. "Hi, Chris," he says, "since your recent post about the bright ISS passes, I have begun paying closer attention to its schedule and noticed this great opportunity on Monday night to photograph it cutting straight through Cygnus in the Milky Way.
Wow.
This is one of those
That's
very
nice.
rare cases where everything went exactly according to plan. Right down.
Where, did he say where it's at?
He doesn't say where it is. He
I
says
like the
it's-
fact that you can see the curve, almost like it's following the curvature of the Earth.
Yeah, yeah.
he says it cut right through Cygnus.
Yeah, so Cygnus is setting
Hmm.
this time of year.
So it's looking to the west. It's almost like he's up on the
That is,
peninsula
yeah,
somewhere.
that's setting right in the west.
Yeah,
That's amazing.
nice shot.
Oh,
Nice shot.
Nice. He said this was one of those very rare cases where everything went exactly according to plan, right down to the weather, and I'm very pleased with the resulting image taken from the side of the highway in Durham Bridge. There you go, just outside of Fredericton.
Oh, okay. That's
Yeah.
by Fredericton, isn't it?
Yeah, it is. Yeah.
Yeah.
So well done.
On January 24th, Sony A6000 f3.5 ISO 3200, 33 8-second exposures plus 11 dark frames, stacked in Starry Landscape Stacker to create clean base image, and then again in Photoshop to assemble the segments of the ISS trail.
Very
Planned using Heavens Above, Sky Guide, and Photo Pills. Nice work.
Beautiful. Nice work.
And this one we have from Annette Smith. Annette says, "We also caught the ISS on Thursday. Thanks for your post about it. It was only 4 degrees Fahrenheit. So we timed walking our dog for when it would be going over. Multitasking," she says. "Here's a shot when it was near Jupiter."
Very nice.
Awesome.
Really
Yeah.
nice.
That's awesome.
There's Jupiter and heading up. Thanks, Annette, for that. We've got Stefan
There's the
Picard
witch head.
here. Here we are, yeah.
Oh, the witch head.
There's the witch head. So
Yep.
Stefan Picard sent this one in. Stefan says, "I've wrestled with this one a bit. Hard to tame. Rigel nearby, but you've got it."
You got it.
Absolutely.
Yeah. Yeah, that's such a bright star, eh, to get that under control when you're trying to capture this fainter nebula.
Yeah. Did a good job, though.
Great
Yep.
job. Yeah. From there, we got this one. I don't know what this is supposed to be.
Oh,
Oh, Jellyfish Nebula in Gemini.
yeah. It looks a little different behind me.
10.5 hours so far, you said? Yeah.
Yeah. Yeah. That's one of those ones you can actually pixel peep. You can zoom right into it. And I'm not sure what it would look like when you stop moving just for a bit. It'll probably settle. And you can move around that. And there are so many cool stars in there.
Yeah.
And just how they're all kind of clumped together and stuff. And the nebulosity, of course, really pops out very nicely, especially in the actual jellyfish portion of it. And so it was 4.5 hours of hydrogen. I'm still actually taking data on that one tonight, actually. But 4.5 hours on the hydrogen alpha, and then 2 hours each on red, blue, and green. And then I took the hydrogen alpha and made a synthetic luminance out of it and put that over top to brighten it up. And the only thing now I got to get is about another 8 hours of oxygen too, because around the whole shell of that, especially on the face where it's the brightest.
Mhm.
There's a whole bunch of blue nebulosity that I think I'm the only way I'm going to be able to get it is with oxygen 3. So anyway, what a great target. And there you go, beautiful remnant.
So what
Yep.
star is that, Paul? Do you know? That's not Castor Pollux, is it?
That's it's right in the feet of Gemini.
Okay, yeah.
Yeah. So there's 2 stars that are very close.
Yeah.
If you go down to the very bottom of Gemini,
Mhm.
and on the top portion, if it was sideways,
Mhm.
there's 2 stars that go about 45 degrees,
Right.
and this structure is right in between those 2 stars.
Okay.
Yeah.
Awesome. Great stuff, buddy. Keep it up.
Thanks.
Got this one from Chris Benoit. He says M42 then and now.
Yes, sir.
Nice stuff.
Oh, look at all this. Yes, sir.
All those
So
captures.
cool.
Yeah.
I love the then and nows.
Yeah.
Absolutely.
Wow.
Well done.
Yeah, that's dedication to one target
Well,
for sure.
Yeah. I tell you, he's spending a lot of time
Yeah.
on there, and that's just awesome.
Yeah.
You come a long way. Like you just see in the progress, right?
Yeah.
Oh my goodness.
Yeah. A little bit
Yeah.
of dedication. That's all it
Very good.
takes.
Looking
Great
really
stuff,
good.
Chris. Really nice.
Well done.
A little bit of change of scene
Wow.
here. Kathy Adams sent this one in. She didn't send it, and I took it from her page. Anyway, just say that she sent it in. Hey, if you're on here and I know you and you're on my friends list, or I happen to know that you follow the page at all, I may go snooping every once in a while and I'm looking for pictures. So, and when I find one that I want to use, and I bring it on the show. So here it is. So surprise.
It looks like the sky's on fire, though, doesn't
Does
it?
say,
Eh?
yeah. That's
That's great.
sunset on the bay in St. Andrews. He says so.
Beautiful.
Beautiful. Great
That's
stuff.
amazing.
The swirls.
She also sent this one in late today. She says, "Hi, Chris.
Today,
Hope you
yeah.
made it through the storm in one piece. Shoveled the porch and got my scope out for a solar image this AM. There you go. That's dedication.
Yeah.
There are shadows across it slightly. I was shooting through the tree branches," she says. "Lots of sunspots, and 2936 is a huge one." Yes, it is. This one right here
Wow.
is getting
Massive.
massive. Many times. Okay, so it would take 108ers to line up across the face of the sun. And so if that's 108, that's got to be at least 5 or 6, maybe even 10.
Easily.
Maybe even 10.
Yeah.
Yeah, Earths.
She
She
also
got she got the penumbra and the umbra very, very well.
Yeah, yeah.
You also got that new one coming across the top that I didn't see.
Oh,
in,
this one here.
Oh,
Yeah.
yeah.
Yeah. I mean, look at that, guys. Look, 1, 2, 3, 4, 5, 6 bunches. I mean, we're not even at solar maximum yet. We're just
Getting
coming
busy.
out of minimum. We're just coming out of minimum.
That's fantastic.
It's great. Lots of sunspots in 2936 is a huge one. She says, hoping for a couple more tomorrow as it's looking to be sunny again. I shot with my Celestron 6 SE with the Celestron solar filter, no reducer, and my Sony A6000 ISO 100, 1/100th of a second. Fingers crossed for more, she says.
Absolutely.
Absolutely. Great stuff.
Yeah. Good job. Good job.
This is from Robert Cadet, and I went in and grabbed this one off his page too, so
Very nice.
whatever. The Milky Way last summer, just outside, standing on my back deck. He says, "Come on, spring and summer, please hurry." Yes, for sure.
You know what part of the Milky Way that is, eh?
No, I don't. I've never looked at this part.
It's my favorite part of the sky.
I've never looked at this part.
There's
I
North
would
American
have.
Nebula.
Is that Leo? Is that Leo?
There's a coat hanger anyway.
Oh, Virgo.
Anyway, the North American Nebula is just looking at us, right? If you zoom in a bit, to
Yeah.
that very big star in the center.
Next slide. Right here. Yeah.
That's Deneb.
Yep.
And right below that is the North American Nebula,
In here.
Pelican Nebula. It's all right there.
Yeah.
If you come back from Deneb just a little bit, there's another bright star.
Yeah.
Just back to your right.
Okay, the right. Okay, this way. Oh, right
Right
there. Yeah.
Yep, that's Sadar.
Yeah.
And the butterflies around there, the crescent nebulae around there.
Oops.
And that M27.
27.
Go to the very tail of that. Go to the tail or the head actually of Cygnus.
Where's
Those
that?
two bright
This way?
stars.
That way.
Nope, to the right. To the
I'd
right.
hate to say, Paul, but if you get close to Sadar, M29 is in there too. It's the cooling tower.
Yeah. Yeah. There you go.
Well, that's the butterfly actually right in there, the butterfly nebula.
Mm.
Anyway, there's tons of stuff in there, but that M27, the apple core that Mike and I talked about, That's at the tail end of that.
Yeah.
And you just go down a little bit, and just below Alberio.
I said, look at the coat hanger standing out there at the other end.
Yeah.
That's cool.
Yeah. And there's Delphinius is down there in the bottom.
Yep, my favorite.
Yep. Delphinius, yeah.
Delphinius.
Yeah.
Del of
I
the
like
Phineas.
Awesome. I'm glad I
Anyway,
grabbed that.
Robert.
Yeah. Anyway, I'm glad I grabbed that one because I like to think about spring too. So let's
There
keep
you
her
go.
coming. This one's here. Who's took this one? Forget now. Gee, would that be Mike?
Mr.
So I
Powell.
said,
Mr. Powell.
you don't see that new spot up in the corner on the left.
Yeah.
Kathy caught.
Well, it's probably yeah.
15
She's
minutes between her and me imaging.
yeah. She's outside the city, so she'd get it before you would. So yeah. Different time zone.
You said you shot that through a window?
Yeah.
That's unbelievable.
Wow.
There was another one I took where I zoomed in and actually got a closer shot of the sunspot. The big one, 2936, and that was shot through a window, double pane window.
Wow.
Wow.
Good stuff.
Boys, you come up some good.
Yeah. And there's another one just a bit. Yeah. Right.
Can you zoom in on that a bit?
I had a. If you go on my Facebook page, you'll see a bigger version of that.
Wow, those
But
are
that was shot
massive.
through a window, yeah, single shot.
That's an amazing sunspot.
I can see
Incredible.
that new spot up in the corner. Just barely see it, but it's there.
Oh,
in
maybe,
here,
yeah. That could have been part of my processing, maybe.
Oh,
But anyway,
great,
those big spots are amazing.
great stuff.
Yeah, nice capture.
Oh, and we got this. Yeah.
Oh yeah.
From
Yeah.
today.
It snowed inside.
Yeah. That happens.
Oh,
look
yeah.
at that thing.
That just shows you a lot of wind.
Yeah.
Everything works good though.
That's right.
Oh yeah.
But I should have took a picture before I walked in. Is what I should have done though, because the computer and everything was white. You couldn't see anything.
I don't know if I can still get. I think there's one more here. Just a second. I see if I can find it. Folks can bear with me for a second, because I have to open up another. I don't know why it didn't pop up. It was sent to me as a PNG file, and the program is just opening up JPEG files, so I might still be able to get it. And it was from Lisa. Inbox. Bear with me. 10 seconds. Hopefully. Facebook is a little bit slow. I think I got it here. Okay. Let's close this. I just want to get that one up there because she had it send it in. So let's put it on the desktop up here. Okay, I think I can get it here. There it is. Okay. Sunspot AR 2936 close up today at 3:18 p.m. EST. So there. Took this with H Alpha, Lund Solar Systems Hydrogen Alpha Scope LS50T, and an iPhone 13.
Yes,
Scope
Wow,
equipped
nice.
with 7.2 to 25 millimeter zoom eyepiece, zoom and cropped. So good stuff, Lisa.
Yeah, absolutely.
Can I quickly show one here, Chris?
Absolutely.
For a second?
Yep. Let me get out of this, Mike.
That'll just be 2 seconds.
Yep.
Dunk,
So
dunk, dunk. Should see that. That was the one I was talking about.
yes.
Oh,
Oh
wow.
wow. Yeah.
And again, that was shot through a window.
That's unbelievable.
yeah.
The clarity you got.
But it came out pretty good. I was
Yeah.
quite pleased with it, actually.
Very nice.
Especially through a double pane window. Like I said, I never had that happen before.
No. Oh, it's
Anyway,
it's
there's
one to
some nice-
watch.
it's huge.
Oh, I
You
can't
can't
wait to
miss it.
try that.
It's massive.
Well, let's keep an eye out, see if we get any M or X class, especially X class solar flares out of that. We might get to see some more aurora here pretty soon. The size of
Yeah.
that, we should be getting some out of that for sure.
It'd be nice.
Yeah.
Somebody said there's KP showing 6 for tomorrow night around 11.
Oh no, really? That must be
Yeah.
brand new then, is it? Yeah, it must have released something then.
That was who said? Was it Lisa?
Okay.
I think it was. I can't tell who said it, but anyway.
Still
Yeah,
all right.
it's exciting.
Oh yeah, KP showing 6 for tomorrow night. So awesome. So let's get a post up about aurora tomorrow night because and tomorrow night's a clear night too.
Yeah, it is.
Locally. So yeah, it might be an opportunity, folks, to get out and take a look. So I'll put a post up. Well, maybe not later tonight, but first thing tomorrow night for sure. About what seems to be happening. So that's good news. Great.
Yeah.
Maybe get a chance to see them yet. Okay, so thanks everybody for those photos, and send them into SundayNightAstronomyShow@gmail.com. If you have any that you'd like to share, we'd love to get them, and I do go snooping. If you don't want to send them in, I'll grab them anyway. Desperate times call for desperate measures. So, but we love getting your photos, so send them in, please, and we love to celebrate what you're able to do out there. So,
Yeah, keep
okay.
them coming.
So in closing then tonight, special thanks once again for your continued support out there. We really appreciate all your support. Special thanks, of course, to Rosanna for another fantastic segment. And to all of you who share our broadcast, we thank you as well. And remember, we do love getting your photos, so send them into SundayNightAstronomyShow@gmail.com, or just send them into my Facebook page, and we'll be happy to include them on our next broadcast. Also looking for suggestions for future shows. Please give us some ideas. We want to be able to get them out there. Yay, please. A couple of weeks in advance is nice, because then we have an opportunity to talk about it before we actually put it together. But if you have anything that you'd like us to talk about, please send them in to the same address, or just send them to my Facebook page. We'll do our best to make it happen for you. And please let your family and friends know that we are here every Sunday night to entertain you and educate you a bit on the night sky. So for now then, from Mike and Paulo and myself, stay safe, everybody. We wish you all clear skies, especially tomorrow night. Wish you nice, fantastic aurora tomorrow night. And as we like to say, guys, keep your scopes pointed up. Night, everybody. Thank you for joining us. Cue the music. Night, everyone.